Okay, so let's look at the convergence rate of, say, one of our favorite conditionally convergent infinite series. Okay, so I'll show you how to formulate this later on, but pi divided by 4 equals the sum in which equals 1 to infinity, or 0, to infinity of -1 to the n divided by 2n plus 1, which becomes, 1 minus 1/3 plus 1 divided by 5, like that. And it goes on forever. Okay? Now, in a class later, what we're going to show is this is a conditionally convergent series. Okay? If I take the absolute values of this thing, I'm going to get 1 divided by 2n plus 1. And when we do a limit comparison test on this, we can show that it is not absolutely convergent. And then we would use the alternating series test on this thing to show that instead of being absolutely convergent, the a sub n in this case would be decreasing headed towards 0. So it's not hard to prove. And so this series is conditionally convergent. Now we have to ask ourselves the question, on the previous problem, we did 4 terms, and we calculated cosine of 1 accurate to 4 decimal spots. Okay. Now let's think about what would the error estimate be in some type of situation like this. Okay. Well, if I did pi over 4 and then minus the sum, let's say I used 1 divided by 3 plus 1 divided by 5 minus 1 divided by 7 plus 1 divided by 9 minus 1 divided by 11, and I used all of these terms, and let's say, let's cut it off right there. Okay. What would this be less than? 1 divided by 13. Okay. If you went all the way out to 1 divided by 99, what is your boundary going to be? It's going to be 1 over 101. So the idea that I'm trying to get across is that conditionally convergent series, they do converge, but they converge very, very slowly. Okay?